Hello, everyone, and welcome to the Injective Global Virtual Hackathon. My name is Albert. I'm the co-founder and CTO of Injective Labs, and today I'll be giving you an overview of Injective's infrastructure. Injective is a layer 1 blockchain for financial applications, and our mission is to create a more free and inclusive financial system through decentralization. The Injective ecosystem is one of the fastest growing ecosystems in all of crypto today. And there's many parts of this, ranging from different DeFi applications to different exchanges and a variety of other services that you can access. A few of the dApps that are built on Injective. Helix is the premier decentralized on-chain spot and derivatives exchange on Injective. Frontrunner is also building a decentralized sports prediction market using the core binary options primitive on Injective, which I'll explain in more detail. There's also other exchanges like Dexterium, which is a decentralized order book exchange, as well as AMMs, or automated market makers, by the likes of Astroport, and of course many others as well. Why build on Injective? On Injective, you have the ability to build next generation DeFi applications. And you can do this really easily by leveraging the existing diverse array of really powerful primitives that are meant for DeFi, designed for DeFi. You can also compose with deep on-chain liquidity on our decentralized and front-running resistant order book. So issues like MEV and front-running that you may face on other platforms that you have to work around, you won't have to do on Injective, given the design of the system. Injective is also very capital efficient due to its order book design, and it's also the fastest blockchain live on Cosmos today. We currently have a 1-second block time, and this number is decreasing every day, which allows you to have a really great UX and also greater economic security. One of the benefits of Injective, unlike other Cosmos chains, is that we have support and compatibility for Ethereum accounts out of the box. So what that means for end users is that the wallet UX is familiar. You can use things like MetaMask, Kepler, Ledger, Trezor, and much more. They won't have to, if they don't have Kepler, they won't have to install it themselves because, they can already use MetaMask. Injective also has support for a variety of bridges across the multi-chain, which includes a native ERC20 bridge to and from Ethereum, and also an IBC bridge for any Cosmos chain, as well as integration with Wormhole, which has over 24 chains connected to it. One of the overlooked benefits or work that a team may have to do when building is indexing data. And the Injective API provides this ready-to-go index data for you. So that can really save a lot of time. And I think that the biggest benefit is that you're able to join a rapidly growing DeFi ecosystem, where you have a lot of opportunity to create something new and grow. So how to build on Injective? There are a few ways. One, you can create a dApp directly on top of Injective's modules. So these can be things like DEXs, as mentioned before, as well as differentiated interfaces for things like more seamless staking, bridging, etc. You can also create applications or services that leverage the Injective API. These can be things like market making bots or trading bots that directly interact with the exchange, as well as a whole variety of different services, whether they be data analytics or aggregators or whatever else you think people may find useful. And I would say the most expressive way to build on Injective is to create your own application using smart contracts with Cosmwasm. And here you can compose with the existing Injective modules, other smart contracts, and the sky is really the limit. You have no restriction essentially outside of what's able to be expressed within the confines of the Cosmwasm virtual machine runtime. So I'll first start with an overview of Injective's modules. The exchange module is the biggest and most feature-rich module available, which contains all the business logic for spot, derivatives, and binary options exchange. So this contains the order book, the matching engine, settlement, etc. Injective also provides an Oracle module, which allows you to access real-time and historical price feed data. Injective, of course, supports Cosmwasm, which is made available through the Wasm module, as well as our own custom Wasmx module, which is a kind of an extension to the existing Wasm module, which I'll go into more detail about. Injective also has a native ERC20 bridge to and from Ethereum. So it's very seamless to bridge tokens over from Ethereum, as well as other sources. And a Tokenfactory module, which allows for you to create your own tokens, or in this case, denoms, so that you can use these as a part of your application. And there are other modules, but I won't be covering these today for sake of time, which include the insurance module, the auction module, and of course, the standard suite of Cosmos SDK modules, which include Authz, bank, staking governance, etc. And I will cover Authz actually on a high level, just because I think it offers some unique features that aren't really found on other blockchains. And yeah, of course, to learn more, you can check out the docs website at docs.injective.network for more details. So understanding Cosmwasm. So Cosmwasm is a smart contract platform built for the Cosmos ecosystem. It uses WebAssembly or Wasm as its virtual machine runtime. And you can develop applications actually using any language that will compile down to Wasm, but the most common one is Rust, as there's a lot of existing libraries and packages that you can use out of the box and other developer tooling. And yeah, applications can be self-contained, as in you only interact with what's contained in your smart contracts or set of smart contracts. Or, of course, they can interact with other smart contracts and even Injective modules. So that way you can take advantage of, for example, the order book or the exchange or the Oracle module, etc. I won't be covering Cosmwasm in depth in this presentation, but to learn more, you can read the Cosmwasm book at this link, as well as watch the upcoming hackathon presentations, which cover, first of all, an intro to Cosmwasm, as well as some more advanced topics in Cosmwasm and Injective. You can also see the CW Injective repo that we have, which contains the Injective Cosmwasm crate, as well as some example contracts to give you a sense of how you can create your first Cosmwasm application. And we also have some walkthrough guides that you can follow along for total beginners to deploy your first smart contract on Injective. So now let's go on to the exchange module. As I mentioned, the exchange module is the biggest module and the most feature-rich one, and it supports an on-chain order book exchange for spot, perps, expiry futures, and binary options. On a high level, it contains the business logic for the order book, the margining system, the matching engine, and the utilization of Oracle price feeds. And these are all on-chain. So the way you can use this in your application is mainly as a source of liquidity. So you can basically get highly composable liquidity out of the box. And yeah, you can do this by interacting just directly with the on-chain order book. And unfortunately, the details of this are a bit too much for this presentation, but you can watch the next Intro to DeFi on Injective presentation for more details. So understanding the Oracle module. The Oracle module provides price feeds for assets from a variety of sources, which include Band, which is another blockchain on Cosmos, which is actually a blockchain that's solely designed for providing Oracle price feeds, actually. And these price feeds are then communicated over IBC to Injective. Pith, which actually has a wide variety of interesting features. The Coinbase Oracle, which is actually a centralized Oracle, as well as custom providers. So here, any address, including your own address, can be a Oracle provider, which means you have the ability to submit your own price feeds. The current markets on Injective don't use these custom providers. just because that would be quite centralized. But we provide this as a basic primitive for you to use in case, for example, you want to create some Oracle price feeds based off some custom logic that you have, which may be off-chain or not. And soon we'll also have Chainlink price feeds as well. So you may wonder, like, why are there so many oracles? Which one should I use? The rationale behind oracles, providing support for all these oracles, is that we don't want to be opinionated about which oracle people should use. Each market can actually, for example, specify a different oracle that it would seek to use, and people can of course decide if they trust in that oracle or not. And more importantly, for your applications, you may find that for example, Chainlink is a good solution, but that, for example, Pyth is better in some other aspects, as it has actually a bit more features, etc. So yeah, our positioning is that providing all these options to you as a developer is the better approach than just sticking with one canonical Oracle provider. So some of the data that's available on chain, well, of course, is the latest price, which is commonly what people care about. But we also support historical prices and the volatility of the Oracle over the last 5 minutes, which can be actually very useful for a variety of applications. We also support summary stats over the last 5 minutes, which include the mean, the median, the min, the max, and the time-weighted average price, or TWAP, as well as time-weighted cumulative prices. And I won't go into the details here, but actually what this allows you to do is compute TWAPs over arbitrary time intervals by this accumulator method, actually. Yeah, and as I mentioned, we also have more stats for information, and this is for Pyth feeds only, which include a 95% confidence interval range. So instead of just getting the latest price, you can get the latest price plus or minus X amount. So let's say the Bitcoin's at 28,000, you can get basically a confidence range interval of, like, let's say $45, and now you know that within 95% confidence that the true price of Bitcoin is within this range. And this can be very useful for a variety of applications. For example, in your application, when, let's say, you're building a lending protocol, you may want to liquidate someone at maybe not the latest price, but the latest price, or the lower bound of the confidence interval, which is, for example, a more tolerant price to use than just the latest price. Or you can also go the other way and be more aggressive. Yeah, so that's actually one very interesting thing about Pyth. They also provide the EMA, or exponential moving average price, as well as the associated confidence interval for that EMA price, which is, yeah, also a very powerful signal you can use in your application. All right, now on to Peggy. So Peggy is the decentralized Ethereum to Injective bridge, which allows you to transfer any ERC20 token from Ethereum to Injective and back. The steps here are quite straightforward, so I'll outline them. As a new user, you first on Ethereum set your ERC20 allowance to the Injective bridge contract in order to grant the permission for the Injective bridge contract on Ethereum to be able to transfer your specified token. You then call the send to Injective function on the Peggy smart contract, which then transfers the token over from your wallet to the bridge contract address. You then have to wait a few minutes, and essentially the tokens will then appear on Injective. And there's a little bit of a naming convention that we use. So, for example, for this token, which is USDT, 0xDAC, etc., on Injective, this token, or denom, or denomination, will appear as Peggy 0xDAC. So we'll prepend Peggy to the actual denom name, and these will be reflected in your bank module balance. Then, of course, you can use these tokens on the exchange, on smart contracts, and on other dApps. To go back to Ethereum, all you have to do is send a message send to ETH on Injective to withdraw the funds back. And then, of course, after a few minutes, they should appear back on your ERC20 balance. And yeah, there's about $10 worth of bridging fees, which are paid in kind. So if you transfer out, let's say 1,000 USDT, you'll have to pay 10. If you transfer 1,000,000 USDT, it's still 10. Yeah. And yeah, there's basically no other steps required. So it's super simple, much faster. We're talking waiting on the order of 5 to 10 minutes as opposed to maybe hours or even days or weeks compared to other protocols. So understanding the Tokenfactory module. The Tokenfactory module allows for the permissionless creation of new bank denom tokens. And it allows any account actually to create a new token with the denom name factory / your creator address, as well as a subdenom name that you can actually choose. So once this denom is created, the creator is given admin privileges over the asset, which allows them, for example, to mint this denom to any account, burn the denom from any account, transfer the denom between accounts, etc., and even remove themselves as an admin if you want to make it like not permissioned. And of course, the admin here can be a smart contract. It can also be empty. So that way you won't have to trust, let's say, an externally owned account for these administrator privileges if you do choose to include them. Yeah, and just as a side note, it can be, of course, important to have these features. For example, if you're creating some LP tokens in your application, you'll of course want the ability to mint and burn these, right? Yeah, the Tokenfactory module, because it allows you to access bank denoms as a primitive, it can be used as an alternative to CW20 tokens. CW20 is kind of the ERC20 equivalent on our standard on Cosmwasm. And yeah, the benefits of this, or the reason why you would use bank denoms with Tokenfactory as opposed to CW20 tokens, is that it allows for simpler application development, as funds can be sent in contract executions directly. So in this case, it's like the message info.funds. The equivalent here would be like in Solidity or Ethereum, like being able to use message.value, but not just for Ethereum, but ETH, but for any arbitrary ERC20 token, right? So you no longer have to deal with these complex approve and transfer from flows. You can just send it directly when you want to use it, which is actually a major UX win. So yeah, no need to manage allowances and transfers. And actually in Cosmwasm, you would need to create sub-messages if you were to do this. And that's the need for that is now gone. If you do choose to still use CW20 tokens for whatever reason, Injective also has a nice CW20 adapter contract, which allows you to transfer your CW20 tokens into the adapter, and automatically it'll mint a Tokenfactory based bank denom for you. So that's yeah, one piece of infrastructure that's available already. And yeah, it's quite seamless. All you need is one transaction, and the tokens are minted. You can see the source code for this adapter contract below at Injective Labs /CW20 adapter. All right. Now let's go over the Wasmx module. So the main purpose of Wasmx is to enable the automated execution of smart contracts in the begin blocker. So for those of you who don't know about the begin blocker, in Cosmos, you there's two things that maybe are different compared to other blockchains, and it's the begin blocker and the end blocker. And what this allows you to do is trigger or execute code at the beginning and the end of each block. So normally on blockchains like Ethereum or Bitcoin, state transitions are made or are triggered by transactions. And of course, you have some other minor accounting things for the block, etc. But primarily, user generated like state transitions occur as a result of transactions. Cosmos allows for you to execute arbitrary logic in the begin and end blocker. And what we built was the ability for you to essentially trigger your own smart contract execution in the beginning of the block. So it's a very powerful automation capability that's unique to Injective. This helps you do away with a lot of off-chain interactions that you may have otherwise have had to do, kind of like a keeper. And yeah, contracts basically have the ability to register themselves to be executed every single block automatically. Of course, gas fees still do apply, and governance approval is required for now to actually have your contract be executed in the begin block or every block. And yeah, in order to take advantage of this, you can create a contract registration request proposal, which will specify your contract address, the actual code ID for that contract, the gas limit, the gas price, and optionally a contract admin, which can modify some of these parameters. Yeah, and every block, the way that this works is that the contract will expose a pseudo message begin blocker function, and if this contract is registered, then it'll be called automatically by the Wasmx modules begin blocker. And yeah, of course, as I mentioned, the contract will be charged the gas that it actually uses, which is the gas limit times the gas price minus the gas used times the gas price, which will be automatically taken from the contract's bank balance. And it's paid in INJ, of course. Yeah, the execution itself, it still preserves atomicity. So if an error occurs, any changes made are reverted. So you won't have any partial executions or anything like that. All right, so that covers the majority of the Injective modules. One of the modules that I thought to also share that's Injective also supports, that's from the Cosmos SDK, is the Authz module. So Authz allows granting arbitrary privileges from one account, the grantor, to another account, which is the grantee. You can read more about the Authz system in the docs link here. But some examples of how you might want to use this, or of how Authz actually is being used in the wild right now, is the ability to auto-claim staking rewards and restake. So, currently staking rewards do not automatically compound. They have to be claimed and then staked again, which can be a bit of a cumbersome exercise for everyday users. So what you could do instead is grant the ability for some other address to send this message claim, staking rewards message for you, transaction for you, and even automatically restake them. So this way you don't have to manage this burden yourself. This doesn't mean that account, the grantee, can just steal the funds from you. because you're just giving the isolated permission for them to claim the rewards on your behalf. So when that happens, the rewards will go to still your wallet. They will not go to the grantee's wallet. And of course, when they restake, they'll be restaking on your behalf. Another example is delegated trading. So this way you can allow someone else to place trades on your behalf if you want to. Injective also has some custom Authz authorizations. So for example, you can restrict trading access to a specific market or a specific sub-account. But that said, there are some security risks just inherent to Authz. Of course, in the first example, someone could create their own validator, and if they're malicious, restake those tokens to their own validator, and then somehow like get slashed, and then of course cause you to lose your tokens. In the case of trading, if you allow someone to trade on your behalf, they can of course buy high and sell low and essentially lose you money. So although it's not the perfect solution for every single use case imaginable, it is a very useful tool. And of course, the design of your application can consider these risk factors and build around them so that such security risks do not exist. All right, now I'll talk about the Injective API. So the Injective API is a high-performance data indexing and API layer for Injective. It allows developers to seamlessly query and also stream indexed on-chain data. So if you are familiar with, let's say, the graph, it's a similar idea. The API does the heavy lifting of extracting the data, transforming it, and loading it into its own database, and also allows you to access low latency, real-time data from Injective. So this currently supports all the relevant data related to the exchange, all the Explorer data, so the data about transactions or blocks, etc. And there are also several SDKs available in TypeScript, Python, Golang, and you can check these repos out below. So Injective TS is the TypeScript SDK, SDK Python is the Python SDK, and SDK Go is the Golang SDK. And to learn more, you can read the API docs at api.injective.exchange, and also watch the upcoming presentations. Well, we'll be doing a deeper dive into the API. These presentations actually are a hands-on guide to building Web3 applications on Injective and a deeper dive into the Injective TS. All right, that's all for today. Thanks for listening.